All right, we are in Unit 1. We're looking in Chapter 2 now as well. Um, and throughout this, I'll be going over some overview videos, big encompassing videos, if anything, small little videos pieced in here. So if you guys need extra help, the point by all of this is the more that I hope that I can put on here, the more this can be self-run if you need extra stuff to kind of review here and there for the course. But here we are in Chapter 2. We're going to focus on data, basically, is what we're doing. All right, and again, if I'm moving too fast, you just need to stop. And it basically says, what are data? Data can be numbers. They can be recorded names. They can be labels, right? But not all data is represented by numbers and numerical data. For example, if I want to talk about males, I could just label them as ones, and twos I could label as females, for example. Data are useless, completely useless, if we do not have a context with what we're talking about. Okay? The W's. To provide context, we need the W's. The who, the what, the when, the where, the why, right? Basically all those W's, those common ones, right? We also need the how. Basically all the questions you can possibly think of, we need to know all of that stuff when we're doing this. The who, what, where, when, why, and how. The answers to who and what are essential, right? They are essential to whatever we do. With data tables, the following data table clearly shows the context of the data represented, right? So I'm looking at this table, okay? And as I'm looking at this table, I can see the who, I can see where, I can see like the prices, I can see the area codes, right? I can see a whole bunch of stuff here. Notice that this data tells us the what column and the who row for these datas, right? It tells us stuff right away. I know everything that's happening at the top. I even have a list of what's happening inside of it. Who? The who of the data tells us the individual cases for each, right? Who we are collecting. Individuals who answer a survey are called respondents. All right, because they are responding to the survey, and people on whom we experiment are called our subjects or our participants, right? Animals, plants, inanimate objects, subjects, they are experimental units, okay? People are subjects. Everything else, they are the experimental units, okay? The who. Sometimes people just refer to data values as observations and are not clear about the who. Okay? But we need to know the who of the data so we can learn what the data says. So what and why? Variables are characteristics recorded about each individual. Those are the variables. All right? They're just things recorded about the individual, and variables should have a name that identify what they are. And to understand those variables, you must think about what you want to know. Okay? Some variables have units that tell how each value has been measured, and they tell the scale of the measurement. All right? So taking a look at this right here. I have the International System of Units linked together, all system of weights and measurements. These are 7 base units from which all the physical units are coming from, right? So if they're talking about distance, it's with meters. If they're talking about mass, they're talking about kilograms. Time, seconds, right? Everything is linked. All 7 of those items are linked to something. Categorical, all right, category, all right, or qualitative variable numbers or variable names. They're categories and answers questions about cases that fall into specific categories, right? Are you a Democrat or are you a Republican? All right, those are categorical data, right? Categorical. Things like sex or race or ethnicity, those are categories. Quantitative variable is a measured variable with units. It's measured. You can do operations on it that answer questions about the quantity of what is being measured. Quantitative things are like income, height, weight, things like that. Those are quantitative variables, right? The questions we ask a variable, the why, all right, those are the shape, what we think about how we are treating the variable. That's the we'll get to those things. Those are called SOCs, basically. I want to know the spread. I want to know if there are outliers. I want to know the central tendencies, the centers, the spread, All right, these are all things that I want to know, right, when we're looking at data. All right, example. In a student evaluation of instruction at a large university, one question asks students to evaluate the statement. The instructor was generally interested in teaching on the following scale. All right, one means strongly disagree, disagree. Three is neutral, agree, and so on. The question: is interest in teaching categorical or quantitative? Right? I know there are numbers, but can I put a quantity on them, like an income or a height, or is it just a number that's representing like a category? Right? All right. Is interest in teaching categorical or quantitative? We sense an order to these ratings, but there is no nature. There's no natural units of interest, right? Variables like interest in teaching, they are ordinal variables. I can rate it, I can give it some kind of order, but I can't really do anything. It's still just a category. With the ordinal variables, we look at the why of the study to decide whether to treat it as categorical or quantitative. The why will tell us, should it be quantities that I'm looking at, or should it be more of a category, right? Counts. When we count the cases in each category of a categorical variable, the counts are not the data, but something we summarize about it. The category labels are the what when you're doing all this, and the individual counts are the who. So again, shipping method, right? This is like saying things like we just said, Democrat, Republican. This is the category of what we're doing. These are the counts that are coming from it, basically. Okay, this is just a. It's not quantities, so it's not quantitative. It's qualitative. It's categorical. We're looking at it. When we focus on the amount of something, we use counts differently. For example, Amazon might track the growth in the number of teenage customers each month to forecast CD sales, right? Which is fine. All right, that's not a big deal. The what is teens and the who is months, and the numbers are the units are the numbers of teenagers. I've been seeing a ton of questions them saying who, what, where, label, all of that. They just want you to realize how to describe data is the point of all this. Do you know the difference between each categories, and do you know how to describe it is basically all that they're getting at with the data. So again, these months, all right, we are looking at, and I can't take all of these and necessarily add them all up. The number of teenage customers in January, in February, in March, in April, right, is what we're looking at. I can't take January, February, and add them up to each other, right? I'm looking to see what happens each month. But they are identifying identifiers. Identifier variables are categorical variables with exactly one individual in each category. Example, social security numbers, right? Tracking numbers of packages. We don't be tempted to analyze identifying variables. Be careful not to consider all variables with one case per category, like year. All right, as an identifier. Some numbers just can't be added together is what they're saying to get anything out of it. The why will help you decide how to treat the variables, basically is what they're saying. We need the who and the what and the why to analyze data, but the more we know, the more we'll understand. When and where give us some nice information too. So for example, values recorded at a large public university may mean something different than similar values recorded at a smaller private school. They just, depending on your location of where it comes from, the data could also be more or less important. Okay? How the data are collected can make the difference between insight and whether the data is pointless. All right, example, results from internet surveys are often useless. The first step of any data analysis should be to examine the W's. This is the key part. You want to make sure that the data that you get is valued. Is it biased at all? Because if the data comes to you and that data is biased, then it was pointless anyway. Okay? Getting some internet surveys and not knowing who's answering the surveys and where their stances could possibly be prior and is it random, it doesn't matter what kind of data you get back from it. All right, and make sure that you know the whys, the whos, and everything else before you analyze the data, just to be helpful. So, what can go wrong? Well, if you don't label a variable as categorical or quantitative without thinking about the questions you want to be answered. Just because your variables values are numbers, you can't assume that they're quantities. And also be skeptical. You need to double check that data and make sure that you completely understand where it's coming from and its purpose. So, what have we learned quickly in this video? Data are information in a context. The W's help with that context. We must know the who, as in the cases, the what, as in the variables, the why, to be able to say anything useful about the data. All right. We treat variables either as categorical or quantitative. All right. And again, sometimes they're called qualitative. Categorical variables identify a category for each case. Quantitative variables record measurements or amounts of something and must have units involved with them. And some variables can be treated as categorical or quantitative depending on what we want to use them for. So they could be both, depending on how you want to use them. So that was a good summary of Chapter 2. And again, I have overviews of these. This is just if you needed like a little refresher of what was happening in our overviews. But I hope that also helped to give you some guidance here in Chapter 2 of AP Stat.